So I stumbled onto this kind of bizarre numerical phenomenon, which is probably very old news, but I just thought it was interesting. So I've got some dice here, and let's say you want to use a die to generate a number, like a random number, um, and you want to generate a, let's just say a two-digit binary number. So that would mean there is four possibilities. You can have, let's say you can have 0, 0, 0, 1, 1, 0, and 1, 1. And, these might correspond to 0, 1, 2, and 3. But the interesting problem, of course, is that a die has 6 possibilities, and you want to use the die to generate one out of these 4 possibilities, and you want it to be even, equal probability of getting each of these possibilities. So you could say for the first bit, well, we'll just say that if the number is odd, then the first bit's going to be a 1. If the number we get is even, then the first bit's just going to be a 0. And that works. And you can roll the die, and so that's even. So we might say that the least significant bit is going to be a 0. And you could roll the die again and do the same thing. Well, it could be a 6 again, but let's just say for demonstration's sake that it's something else. So you get a 4. Well, that's even too. So you could say we got 0, 0, and you keep doing this. Except you might wonder if there's maybe a way to generate two numbers, or to generate the entire two-digit binary or two-bit number with just one die roll. And you could say, well, we'll just say that for one of the bits, if the number is even, then it's going to be a 0, and if it's odd, then it's going to be a 1. For the other bit, though, we could say that, well, if the number is 3 or lower, it's going to be a 0. If the number is higher than 3, then it's going to be a 1. And at first it might seem like, well, that makes sense, because there's a equal probability of it being 4, 5, and 6 versus 1, 2, or 3. So there's a 1 and 2 probability. There's a 1 and 2 probability of it being 1, 2, or 3. And there's also, of course, a 1 and 2 probability of it being 4, 5, or 6. So that seems to work out, that we get an even probability for that bit. And of course, there's also, the same goes for odd versus even. You got 1, 3, 5. And then the other possibilities are 2, 4, and 6. So there's also a 1 and 2 probability that the number you're going to get is even versus odd. But an interesting thing is that this isn't going to work, because if you let's just iterate through all the possibilities. So if we roll a 1, if we roll a 1, then that would be, let's see, 3 or less. So the first bit would be 0, and then that's an odd number. So the second bit, we were saying that odd would mean a 1, so the second number would be 1. Let's say we roll a 2. Well, that's again 3 or less. So first bit's going to be a 0. It's even this time though, so the second bit is also going to be a 0. What about 3? Well, 3 is still 3 or less, so we're going to have a 0. And it's odd, so the least significant bit is going to be a 1. Okay, now 4. Well, 4 is greater than 3, so we're finally going to have a 1 here. It's even, so we're still going to have a 0 here. Skipped over 4 there, but on the die. But now let's say we have 5. Well, 5 is greater than 3, so we're going to have a 1. And it's odd, so we're going to have another 1. How about 6? Well, 6 is, of course, greater than 3, so still have a 1 here. And it's even, so we have a 0 here. So when we roll the die, there is a 1 in 6. There's an equal possibility of getting one of these 6 numbers. And so certain numbers have a 2 in 6 probability, and then certain other numbers have just a 1 in 6 probability. Even though these two events both have a 1 in 2 probability of happening. And so it's just interesting that out of two events, normally if you have something that's 1 in 2 probability or 1 in 2 chance, 50% chance, and you have another thing that's also 50% chance, well, the odds of both of those things happening usually would be 50% times 50%, or 1/4, or in this case 1 in 4. But it's not the case here, which is kind of strange and interesting. And like I said, I'm sure this is very old news, but I just thought it was interesting.